This video is going to cover page 3 of the Chapter 3 test, version 1. And we are told in this problem to solve for x in the diagram below, and we're given a big hint. Use one or more auxiliary lines. Okay, there's a variety of ways that you can solve this problem. But many of you knew that, alright, well, I've got these parallel lines here, so I'm just going to extend them a bit. Okay. And then I've got, let me fix that for you. I've got some transversals going through these parallel lines, but they don't really extend very far. So let's take this one and this one and make them a little bit longer. And then now I've got two triangles that I did not have before. And we know that triangles sum to 180, so they're really powerful. What could I fill in here? What information do I know? Well, I see some straight angles that I could fill in. So I know that I've got 126 over here. So this should be 180 minus 126, and that's 54 degrees. And I know this is a straight angle, but I don't know what x is yet, so that's not really going to help me. So is there any way that I could figure out something else, maybe in this triangle? Well, 134 should be supplementary with this angle here. Why do I say that? Well, those should be same side interior angles, and we know that they're supplementary. So 180 minus 134 would give me 46 degrees. Now I know 46 and 54, so I could find the third angle of this triangle and then use straight angle again to get to x. But hopefully you remember that the exterior angle of a triangle, so I can consider x, the exterior angle of this triangle here, is equal to the sum of the two remote interior angles. So x should be equal to 46 degrees plus 54 degrees. And indeed, that adds up to 100 degrees, so I can fill that in. Okay. Now that's not the only way that people solved this. There were actually quite a variety of ways that people solved it. I'll cover one of them. One of the more common ones that I saw was, let's see, some people said, you know what, I'm going to make a pentagon. I guess this angle over here sort of reminded them of a pentagon, so they just decided to go like this. Okay? And they just decided that this new transversal through these parallel lines should hit at a 90-degree angle. And of course, if it's 90 here, then it's 90 everywhere. Okay? What do we know about pentagons that's so powerful? Well, we know that pentagons follow this rule for the sum of their angles, which is n minus 2 times 180. That would be 5 minus 2 times 180, or 540 degrees. 540 should be the sum of all of these. So let's see. We've got 134, which is known, 90 and 90, which we created, and 126 plus x. And when you solve for x, you get 100 degrees. Again, there were lots of ways that people did it. I even saw a hexagon like this, and then a similar maneuver with the n minus 2 times 180 formula. So lots of ways that you could get to the answer on this one. All right, moving on to the next question. Solve for all values of x. Okay, we've got some parallel lines here. We've got a parallel line here, parallel line here. Okay, together they're parallel. Now, I know 50 degrees up here, 80 degrees here, 2x squared minus 7x down here. Okay. So what a lot of you saw initially was 80 degrees kind of outside of these two triangles. So I saw a lot of people putting 100 here. Okay. And then people knew that 150 makes 150. This triangle should have a total of 180. So 180 minus 150 left us with 30 degrees. Now there was a shorter way of figuring that out. We didn't really need the 100 because we know that the sum of the remote interior angles of a triangle should equal its exterior angle. So all you had to do was 80 minus 50 to get to 30. What's so powerful about 30 is if you check this out, 30 and its relationship to 2x squared minus 7x. Well, if you consider this to be your transversal, okay, and then we see our parallel lines. I'll put the parallel lines in blue here. 30 degrees and 2x squared minus 7x are alternate interior, and we know that alternate interior angles are congruent. So 2x squared minus 7x equals 30 degrees. That wasn't the only way to do it. Some people went ahead and figured out, let me erase a little bit here. Some people noticed that, hey, 50 degrees is alternate interior with this angle. 80 plus 100 makes a straight angle. And then they summed this triangle here to 180, which is a fine way of doing it. So they said 100 plus 50 plus 2x squared minus 7x equals 180. 150, when we combine our constants. And then, hey, look, 150, 180, if I subtract 150 from both sides, guess what I get? 30 degrees. 2x squared minus 7x equals 30. So lots of ways to get to this quadratic equation. Now, I say quadratic equation because the highest exponent I see is 2. So 2x squared minus 7x minus 30 equals 0. You know, I'll drop that degree symbol for the moment while we solve our quadratic. We don't want to distract ourselves. And sorry about that. Alright, I've got to solve this quadratic. Now, some of you know how to factor with an a term that is higher than 1, but most people did choose to use the quadratic formula. So that's what I'm going to use to solve this. So we know quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Our a in this equation is going to be 2, our b is negative 7, and our c is negative 30. So, negative b, well, that would be negative negative 7, or 7 plus or minus the quantity negative 7 squared. Minus 4 times a is 2 and c is negative 30 all over 2 times 2. That gives us 7 plus or minus. You end up with 49 plus 240 under here all over 4. That's 269. Which is a perfect square, gives us 17. 7 plus 17 is 24, which we divide by 4. But 7 minus 17 is negative 10, which we divide by 4. Okay, so let's see, we've got 6 or negative 5 halves as our answers. Now, a lot of you did choose x equals 6 as your answer. But many of you threw out negative 5 halves because I guess you figured it was negative, it would make the angle negative. But interestingly enough, when you plug these in, they both end up working. So check them both with your calculator before you go ahead and toss out anything. Both 6 and negative 5 halves satisfy the equation. And that concludes this video.